We used this equation previously to model protein production. Now, I want to introduce you another model. So y of I is equal to P1 times x of I minus 1 plus P2 times x I minus 2. What do we have here? This time, we are saying that current Y protein concentration depends on x of I minus 1 and x of I minus 2. Let us assume that the time interval is 1 minute. Then we are saying that the current Y protein concentration depends on X protein concentration 1 minute ago and X protein concentration 2 minutes ago. And this parameter P1 and also this one P2 tells us that how much each X contributes to Y. So if this value is large, then X of I minus 1 is contributing to Y of I a lot. Let us assign some values to P1 and P2. For example, let's say we have 2 times xi minus 1, where P1 is 2. And here P2 is 1, so we just have x of I minus 2. Now we have this equation. So we have x here, and we have time 0, 1, 2, 3, 4, and so on. So this is I, or discrete time index. And we also have y here. So this is y of I, and also starts from 1, 2, 3, 4, 5, and so on. Let's say we have value 1 at time 0 for x. So at time 0, we have x of 0 value, which is 1. Now, from this expression, we know that y of I is contributed by 2x I minus 1. Or you can say y of I plus 1 is contributed by 2x of I. These two expressions are saying the same thing. Then we can say if we have an x of 0 here, we have 2x of 0, then that contributes to y of 1. So if we have a x0 here, and the value of that is 1, then that will contribute to y value at time 1 here. The value will be the twice of x0. So we will have 2 here, because x of 0 is 1. So this y of 1 will be 2 times larger. Now, we also have this component, and y of I is contributed by this x I minus 2. And similarly, we can say that y I plus 2 is contributed by x of I. And that means when we have x of 0, we will have y of 2. So again, this x of 0 will contribute to y at time 2, because we have 2 here. And the value or the magnitude will be the same as x of 0. So basically, this x of 0 will create these two y values, y of 1 and y of 2. Now let's say we have another one, and this is x of 1. And similarly, we can say y of 2 is affected by 2 times x of 1. So this one will contribute y value at 2, and the magnitude will be 2 times this one, which is 2, right? So we will have 1 and 2. Also, we know that this x of 1 will contribute to y of 3. So this one, again, will contribute to y at time 3, and the magnitude will be same as x of 1. Now, if you look at y values here, we have 2 at time 1, and at time 2, actually we have 3. So the first component is contributed by this x value, and the second component is contributed by this value. That's why we have 3. So 1 plus 2 is 3. And at time 3, we have 1. Each value of x contributes to y. And in order to find out the final y values, you need to add all these contributions together. And this is called convolution.